welcome everyone who is now on the call. Let me have a look. 9 people are on the call. So without further ado, let's start with the main part, namely this presentation by Giovanni. Hi.
Thank you.
Giovanni, can you share your screens? I see already your screens.
Okay.
Everyone has a problem with seeing the screens about DALI?
Okay,
no,
I'm doing.
Please go ahead. 20 minutes.
This is full screen now. Okay. Thank you everybody for coming to listen to me to this webinar. And I will be talking about DALI for cognitive robotics applications, mostly based on DALI, and as a declarative logic-based multi-agent system. We will have some robots, some real robots, maybe also some virtual robots. You can think about some talking head avatars on a screen that will have to deal with humans. So that those humans will be kind of patients. They will be chronic disease patients that have to be monitored by physicians, and they have to be carefully checked every day on medication and things to do. Since the combination of sick status may be very critical for their health. And then we're going to have a lot of software on back end, which possibly will use some bridge rule engine that should be able to gather knowledge from many different dishomogeneous sources of knowledges. And also using taxonomy and terminology rules and pattern rules of behaviors to trigger given some conditions. So this is the main goal of our project. And so I started from what we quoted in the paper, the concept of cognitive robotics, very interesting because as defined by IEEE, there is a growing need for robots that can interact safely with people. So I bolded those words that are very important in this context and in everyday situation. These robots have to be able to anticipate the effect of their own action, as well as the action and needs for other people around, and so on. Another very important thing is to interact with unconstrained environments, obviously, and to acquire and use experience, which maybe be the most difficult part. But we were kind of focusing on one aspect at a time. So probably logic-based multi-agent system would be very useful on self-checking conditions so that safety is kind of assured or at least maximized. So let's see more about this kind of robots. You may have already known about the concept cobots. These are collaborative robots that are robots that intended to physically interact with humans in a shared workspace. In, for example, a new factory, 4.0 manufacturing context, usually you have a robot arms very close to humans, and so they have to be careful how they move. They have to be aware of the human presence, and they usually should be moved by hand, softly and gently, and so they have to have special control, electronics and software. So even if we are mostly interested on the cognitive part, which is the higher abstraction part, so this is definitely important when you have a machine close to a human that should understand the safety rules. Also, mostly interesting for us is the class of care robots that are specialized to assist humans at home mostly. And there are many research projects on this. Somebody is thinking that maybe in the not so far future, elderlies will be mostly cared by machines, since due to the lack of people that can, mostly the large number of elderly that will have to need help. So again, you have a robot, a machine in a shared space with the human that has to move gently and to avoid safety issues or harm to the human, and sometimes feed the human or help to raise by chair or other things. Obviously, it would be nice to have this kind of robots in our lab, but they're very expensive at the moment. I think no less than $100,000 each, probably. So I will explain you how we are kind of simulating these setups. So concentrating on care robots, we had a look at this proposal from Professor Johan Horn at the University in Amsterdam about social robotics, where the focus is not just artificial intelligence aspect, but the impact of robots on the user interaction, the user experience, basically. So maybe we should talk about the robotic user experience coming from the web user experience. Also, including ethics and rules to interact with disabled, and have an acceptable robot appearance. Obviously, robots are not fully autonomous. Mostly at this time of the evolution, they are mostly drones guided by medical staff from a remote site, like a company robot that can be seen on this documentary Alice Care that with Stefania we were looking at. I hope this will start easily. You can have a look later, but I will just show you a few seconds of this video. It starts, and it's basically a simple kind of company robot that is making giving some kind of basic service to an elderly. So the person will be able to talk to it, and then so it's an advanced chatbot basically. And sometimes there is a medical staff behind that is looking through keywords that are exchanged between human and robot. So this would be a nice first setup that we can investigate. Also because I have been doing some chatbot research lately, and so we can introduce monitored chatbot embedded in a real robot and try to see how they behave with humans. Then let's talk about this part of the robot control that would be done by multi-agent systems defined by declarative agent-oriented languages. So mostly task would be observe the user and monitor the user behavior. For example, in relation to how he's taking the right medication, is doing things at the right time, and also monitoring and also training the user, because the user has to be trained to do that things over the day schedule. So the robot needs to have a basic user profile that where this profile should store everything about the user needs in terms of medication, habits, and also preferences. So not to forget, even if you are sick and you have to eat vegetarian, for example, some specific diet, you may still can select, preferred food from standard food, let's say. And so also the reaction that should be is expected from the robot when the robot has to cope with a specific situation, and also some proactivity that we have been defining in DALI by using internal events, preconditions, and so triggering actions from the multi-agent system that will trigger a behavior in the robot, so that it will take care of the user, for example, a specific time of the day, or an event of some logical condition that is becoming available. Definitely, there are many logic-based languages framework to do that that are here listed. We actually also doing some agent speak JSON multi-agent system experimentation, and definitely DALI, that is our proposal. DALI, as you may see from the paper reference, it's a long time been developed here in L'Aquila by Professor Stefania Costantini. Her team, I've been added to the team like 4 or 5 years ago. Now I'm in charge of the software maintenance and extension. You can actually get it from GitHub. It's an open source framework, even if it's now based on Prolog, Sixtus Prolog proprietary software, but we're already working on porting on SWI Prolog. I think by the summer we may have the first DALI fully 100% open source version. And this is a very layout, a very general layout of internal Prolog modules of DALI, mostly based on reactivity logic, proactivity, and an action layer that is including all of the external messages sent out from each agent to the rest of the agent community or external world. A message layer done with the Linda tuple space, which is a well-known and very long time used system for messages. We are now investigating some new way of exchanging messages, more based on publish subscribe kind of message passing logic, and also short and long term memory done by assertion and retraction on a logic knowledge base, and a complex event processing layer which is based on temporal logic. So it's quite complex. The full code can be analyzed, and you can help us to let it more to be precise on everything that we expect it to do. So how we think to use DALI for care robots? Well, we should have at least one agent per user, and we have 3 main aspects to address, which is learning, monitoring, and training. Learning what the user usually does, monitoring what the user is expected to do, and train the user to do what the medical staff say the user should do. So the knowledge of this agent is not static, it's an evolution with time. So we, in a sense, can be considered to be learning, but we are talking about imitation learning, basically kind of learning based on examples, possibly, and induction logic. And so I'm not saying this is our aim, okay? So we are in a work in progress, and this is our roadmap in a sense. So everything is being built from the bottom up, and so we will study with our students and our PhD students how to proceed to implement these aspects. For example, let's see, we have a user profile with some constraints that this user should not, it's about diet, And so this user should not drink alcohol at the same time take some medicine, which also needs to include some temporal logic, because the medicine takes time to go into the bloodstream. So at least if you can have probably one small glass of wine, which is far from the medicine time, and then the care reaction that is based on preferences. So if the user is hungry, the robot should provide food from the list of available food that is probably defined from a diet, and what is best preferred and healthier from the user point of view. So this is some syntax we are already implementing on DALI, and so rules could be easily written and understood, and also from lay people that it's not necessary an artificial intelligence engineer. So let's go down to the software architecture, how we intend to extend DALI. And here we have the conventional DALI interpreter based on Prolog, which has its own communication layer based on tuple space. But we already encapsulating in a Python class object, so that we could start, stop, and add agents, remove agents, give agents behaviors from a Python script, and also having an HTML5 interaction GUI with the multi-agent system user, and using other buses other than the Linda tuple space, like ROS, which is a robotic operating system channels, that are mainly used in robotics nowadays to exchange data on robot sensors and actuators. Redis is a very interesting key value store database, where has a very efficient publish-subscribe channel of exchanging events, and particularly this is being used with a local company for a complex event processing application in ambient security. And YARP is similar to ROS, is a sensor actuator bus system developed at the Italian Institute of Technology for the iCube robotic project. Also, we are experimenting with many different virtual robotics environment, Gazebo, Unity, Open Simulator, iCube, and VREP, where we can set up some virtual robotics experiments that are mostly cheap, much cheaper than the real robot. This is a typical runtime deployment of DALI, where we have a central multi-standard DALI bus where the agent will exchange messages. So these messages will be events that can be also exchanged between DALI agents and Python processes, and a browser embedded web user interface, some external sensors like temperature, humidity, or comfort sensors in the room where the patient is located, a log server to have a black box of what happened. You may imagine when there is some legal issue to be investigated, you have to know exactly what happened. And so all of these modules have been developed now these days. I can tell it's about 80% implemented, and we're already testing. If I have a few more minutes, I can show you some preliminary. It's okay, Harold? I can show you some videos done with our students. Mostly these are, for example, some mains solvers with the heuristic logic implemented in a VREP virtual robotic environment, where there are some Python glue code that encapsulates the logic, and then the robot is being driven by this agent-based controller, and by using some heuristic it can easily find the exit of the maze. or this is starting to investigate some simulation where some humans are around. So VREP is a nice virtual robotics environment that can allow us to simulate humans in presence of robots. So a robot is running an obstacle avoidance algorithm that should also take into account the working person around. And just to finish this very small example, which is related to one of the latest slides, since it's already 20 minutes. This robot here is a very nice toy, but it has been very useful to investigate this cognitive aspect, since this robot wants to stay in equilibrium, and so when you give a command by Bluetooth, usually is kind of a stochastic actuator. So we did this basically with the top camera, giving a command by Bluetooth to the robot. We want the robot to avoid these virtual obstacles, which are just piece of paper, colored. And so this way I was able to introduce computer vision in the loop. This is what one of the agent, the procedural agent, is generating events. This is what the robot says, mostly the camera, the top camera sees. And so the blue square is where the robot is located. And when there are collision, these are the point of collision that are previewed by the logic just by making a difference between frames and the original frame of the scenery. And so the robot could avoid those virtual obstacles, knowing where the collision is going to happen. So basically, I don't know if that's it for now, and I'm open to questions, if that is okay with the Harold.
Thank you so much. Yes, please ask your questions.
Yes.
Yeah, so I have a question about your maintenance goals. So you want to have always a warm environment and so on. How do you check these constraints? Like in cybernetics, to maintain some feedback control?
Well, we think that all of the events related to the scenery, they should be known to the system. Every change, every signal, variable interval, and what can be measured, that should be measured. And then we write some constraints that should be always be true. And we also are implementing an answer set programming solver, which will be embedded in one of the DALI agents, so that this solver is always running on the cloud, checking for constraints. So whenever there is some fluence become true and the constraints are not respected, this will actually generate a new event that will go through to the bus. So some agents have to reason upon that constraint being violated.
Thank you. Other questions? Otherwise, thanks again, Giovanni. It was fantastic.
Okay, thank you very much for listening.
People can contact you easily. For instance, I can send you an email. You are the first person on my field of my invite in my email. People can easily send you emails.
Yes, sure. Yes, I will be
if
happy.
I want to follow up
I will be happy to do
right.
that.
Also in Skype, maybe. Thank you again,